So for question 2 of the exam is to compute the volume of the solid form by revolving the region bounded by y equals x squared plus 1, y equals 0, and x equals 1 about the y-axis using any method. And we start by sketching the region, finding the limits, finding the height and radius of the shell, if we're using shell method, and D, setting up an integral of the volume of the solid, and finally finding the value. Now to sketch the region, we know that x squared indicates it's a parabola, and y equals mx plus b. 1 is the intercept, which means that 1 is going to be the vertex of our parabola, and it's just going to reflect around the y-axis. However, if we didn't know this, we could just plug in and find our equations using random values that we want. So I'm going to use -3, -2, -1, 0, 1, 2, 3. And we just plug in our x value into here to find the y coordinate. And so y would equal -3 squared plus 1. 3 times 3 is 9, plus 1 is 10. And that's our answer. And we repeat this down the line. And these are going to be the values that you find. And since it's a parabola, of course, it's reflected around the y-axis like I said. This is our vertex and the intercept, like I had said. And now we're ready to graph our line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. 1, 2, 3. All right, so our points: -3, 10. -2, 5. -1, 2. 0, 1. And it's reflected. 1, 0. 2, 2. No, 2, 5. Sorry. Read it wrong. And 3, 10. And these are our points. So this is our line right here, a parabola. And now if we look closer, we see it's bounded by y equals 0, which means that we're not going to pay attention to this side. And bounded by x equals 1, which is right here. So this little region right here is what we're finding the volume of. So I'm going to sketch it a little closer, and I'm deciding that since it's rotating about the y-axis, I'm going to use the shell method so I don't have to manipulate the equation to use y values instead of x. Now, this is what the region looks like close up. And to rotate it about the y-axis, we draw the figure as if it was reflecting about the y-axis. Because if it's spinning around, this is what it's going to look like. And this is the figure of what we need to find. Now, to use the shell method, you're going to first draw a smaller shell because all these shells are going to add up in an integration to find the total volume. And when using the shell method, the sides are going to be parallel to the axis you're rotating, which is y, so they're parallel to y. And this smaller shell is going to look like this. I'm going to color it in so we can see it clearer. And here it is. This is the diagram that we need to look at. Now for part B, we're going to find our bounds. Now, we know that since right here is 1 and here is 0, that's our bounds. But we could also use the two equations that are given to us, y equals x squared plus 1 and y equals 0. And we set them equal to each other to find the intercept. So x equals -1, x squared equals -1, which means that x will equal plus minus 1. However, it is bounded by y equals 0, so we know that we're not using 1, -1 because we're not going over here, like I had said earlier. So our bounds will be the positive 1 and 0. These are our bounds. Now we're ready to use the shell method to find it. So the shell method, when we're calculating the volume, we know it's the circumference, because we're using the cylinder, times the height, times the thickness. Now, the circumference will equal 2 pi r, because you see it's a circle. Now, the radius is going to be this right here in the diagram. And if we look closer, the radius goes like this. And what is these values right here? They're just x. Any region, any value right here is x because these points are x, which is what we're looking at. So the circumference equals 2 pi x. And the height, this is the height right here. And what's this value? Y. So y is equal to f of x, which is equal to x squared plus 1. And so we put this in as the height, and the thickness is just dx. And now we're ready to set up the interval. So v, volume, we're going to take the 2 pi out of the integral because it's just a variable we could put in later. Our bounds, 1, 0. X squared plus 1 dx. So we're going to simplify this before we integrate. X cubed, x1 times x squared, plus x dx. So v, now we're ready to integrate. To integrate, we do the exponent plus 1 over the value of the exponent plus 1. So 3 plus 1 is 4. And we do the same for the x. And now we just plug in our values to finish the integration. So 1, 4, plus 1 squared over 2. Now we normally would use this lower bound and do the same thing after subtracting it, but we know that all zeros put in here will just be 0. So we have v equals 2 pi 1/4 plus 1/2, which goes to v equals 2 pi 3/4. Multiplying this all together, we have the volume equals 3 pi over 2. And that is our final answer.